All right, yesterday we started talking about normal distribution, characteristics of normal distribution. Today what we're going to do is we're going to start getting some mathematics behind it, some applications behind normal distribution. When we're dealing with normal distribution and a bell-shaped curve, we need to be able to standardize our data values. Okay, so when we have a standard normal distribution, it happens when we convert all of our scores, our data, into z-scores. Okay, so when we convert all these data into the z-scores, when a set of data is converted into z-scores, the mean of that set of data is still going to be a value of 0. Okay, when we say we standardize a set of data values, that means we've changed them all to z-scores. We've changed them all to z-scores. And with the z-scores, the mean of that set of data is going to be a value of 0. And how we calculate those z-scores is value minus mean divided by standard deviation, which is x minus mu divided by sigma. And once again, this will be a test question for you. The mean of the set of data, when you standardize a set of scores, the mean of the set of data is a value of 0, and the standard deviation is a value of 1. And once again, that will be a test question. And how we calculate that z-score, once again, is value minus mean divided by standard deviation. Now, this might be when we're dealing with a sample, it may be x minus x bar divided by s. It does not matter. Anytime that you subtract off the mean and divide by the standard deviation, that's going to give you a z-score. Now, what we've talked about up till now is when we talked about area, that was also the same as probability. Case in point, the idea of our weather. When we look at our weather and the weather map, maybe. We look at what we have here. This is all rain. This is all rain that we're dealing with here. I can get it to whiten out, and I can't get it to whiten. Let's use that. If we get this to whiten out, it shows us the rain and the precipitation that we have. Radar. And if we take a look, all that is rain. Now, if we take a look at the probability of rain on the hourly forecast, they're predicting right now 94% chance of rain, which, if you remember back to what we talked about yesterday, 94% chance of rain is also 94% of the area is covered in rain. So there's a connection between the probability and also your area. When you talk about probability percent chance of rain, you're looking at also how much of the area is covered in rain. So when you talk about probability, there's going for 100% chance of rain here in a little bit. That means the entire area is going to be covered in rain. The whole area is going to be covered in rain as we go throughout this. So the probability that we have of this rain just tells you how much of the area is going to be covered in rain. 95% of the area, 86, it starts to diminish out a little bit. So when you talk about area, you talk about probability. So area is equal to probability. Well, what we talked about yesterday was the area underneath this curve is a value of 1. The area underneath this curve is a value of 1. If we have a z value, I gave you a table. Okay, you have a table at the bottom here, and I'll also give you a second table that's a little bit easier to work with. Okay, this is a z table. This is a z table that will calculate this area. This will calculate the area. This table represents area between the mean and the z-score. The mean and the z-score. So when we utilize this table down here, we are calculating the area. The area between the mean, which is our 0 value, because when we're talking about the mean of a set of data, that's your z value of 0 and a z-score. So this table will allow you to give you an area between here to here. But we also know with this area, this is going to be a probability. This will be a probability. How the z table is read? If we look at the z table, what we have here is we have a z-score, the whole number, and the first decimal place here. The second decimal place comes up here. So we have to be able to say, or look at a z table, and suppose I have a z value of 1.23. A z value of 1.23. I will scroll down my left-hand side till I get to my 1.2. And then I will take that row over to 0.03, which is up here. So I'm going to come here and I get a table value of 0.3907. Which tells us this is the area. If I do a little bell-shaped curve here, and you'll be doing a lot of these. My z value of 1.23 and my z value of 0, which is my mean. This area right here is equal to 0.3907. Which can be also translated into a probability of 0.3907 or 39.07%. Find the area between the z-score of 0 and 2. Now, what I'm going to ask you to do each and every time is draw a bell-shaped curve. Your 0 is going to be at the middle. And we have a z-score of 2. Now, if we take a look at this as a number line, this is a number line. Here's my 0 value. So going to this direction on my number line will be positive. Going in this direction will give me negative values. Because it's just a number line. Think of it as a number line. If I had a number line, I have 0 here. Going to the right is going to give me positive. Going to the left is going to give me negative. What I want to calculate is the area between 0 and 2.00. So if I take a look at my table, once again, that's why I gave you the second sheet so you don't have to flip back and forth. I'm going to scroll down my left-hand side to 2.0. And then go across to the 0.00. What is the table value you get, Braden? 0.4772. So this area here is equal to 0.4772. And once again, you can look at the very bottom. It gives you a little chart down there at the bottom also. They don't have the shade, but they have the mean at 0 and then your z-score, and the table will give you the area there. So this area will equal 0.4772. What would be the area between 0 and 1.50? Once again, draw this because it will help you as you go along. I know these are very basic. I don't anatomically correctly draw these because I just like to have enough space to write in. So I'm going between 1.5 and 0. What is the area between 0 and 1.50? Compare your answers to somebody around you. Aubrey, what do you come up with? 0.4332. So that is this area. Find the area between the z-score -1 and 1.5, or I'm sorry, 0.5. Get our middle value here. Now I got a 0.5 and -1. Now, there's no magic, find one answer from your table and be done with this. Because the table will only give you values from 0 to a z-score. So the table will only give us values from here to the z-score. So if I look up at my table, 0.50. Lauren, what value do you come up with? 0.1915. That is this area right here. That's why I give myself a little bit of space so I can write that in. Well, the problem we run into is, how do I deal with -1? My table doesn't have any negative values in here. How do I find a value for -1? Anybody have any suggestions? Why can't I just use +1? Yeah. The characteristic we talked about yesterday. We are symmetric. We're symmetric. So what you see on one side, you must also see on the other. So we can look up 1.00. We look up 1.00, Andrew, what do you get? 0.3413. Well, I want to find this entire area right here. So what should we do, Brianna, with these two values? Add them together. So we have 0.3413 plus 0.1915. Please show what you're doing with these numbers. Because sometimes you're going to be adding them, sometimes you're going to be subtracting them. Sometimes you're going to be adding to 0.5, subtracting from 0.5. If you have the correct table value, you will get partial credit. If you have the wrong operation, then you're going to have some points marked off. So I add these together, and Brandon, what do you come up with? 0.5328. That is my area here. From -1 to 1.75. Go ahead, draw your table, or draw your bell-shaped curve. You're going from -1 to positive 1.75. Find your two table values. What are we going to do with those two table values? Check your answer with somebody around you. Katie, what do we have to do with these two values? And what do you come up with? And that is this area right here. Find the area to the left of the z-score of -0.5. To the left of the z-score of -0.5. So I want to find this area right here. To the left of 0.5, -0.5. Now, what our table will only find is that we'll calculate the area from the 0 to my z-score. So if I look up my table value, 0.50, Mason, what do you come up with? What's the table value for 0.50? That gives me this area here. How do I calculate this area out here?
0.5 minus 0.1915.
0.5 minus that value, because the entire, okay, let's think about this, characteristics. The entire area is equal to 1. I have to be symmetric. So the area to the left here is equal to 0.5. The area to the right has to equal 0.5. So my areas have to be 0.5 because I have to be symmetrical. Well, this is 0.1915, so I can subtract off 0.5 minus the 0.1915. Isaac, what do you come up with? And once again, show me what you're doing here. Show me what you're doing. What would be the area to the right of that z-score? Once again, hopefully you can see where these pictures help you out. We already calculated this area to be 0.1915 from the table. Now I want to go to the right. So I want all this area right here. What should we do to calculate the area to the right of this? Grace, what should we do to calculate the area to the right? Subtract them. I want to find all this area over here. This area is 0.1915. What's this area over here? Add them together. So I'm going to take the 0.1915 and add it to 0.5. Once again, show me what you're doing here. So we have 0.6915 would be that area. Good. Calculate the area to the right of the z-score of 1.23. So I want to calculate that area there. Go ahead and calculate it. Check your answer with somebody around you. Piper, what's our table value? .3907. 0.3907. Good with that? Okay, what are we going to have to do then to find this area, Piper? So we have 0.5 minus 0.3907. What do you come up with? 0.1093. Once again, not going and on about mathematics here, but need to make sure that you show me what you're doing. Hopefully, you look at the table and you can see, or your the picture that you're doing, and that helps you figure out what you have to do each and every time. Sometimes you'll add values together, sometimes you'll subtract them. Sometimes you'll add to 0.5, sometimes you'll subtract from 0.5. Now what I want you to do is, if we take a look at the front here of the worksheet. The front of the worksheet is exactly what we've just been doing. Every time you should draw a bell-shaped curve. What I want to take a look is on the back of the worksheet. Because what I ask you to do is find the probability. Find the probabilities. What I want to do is take a look at problem number 14. Problem 14. Problem 14 is the probability that the z-score, bless you, the probability the z-score is between 1.2 and 2.1. You're doing the exact same thing because on the front side we talked about area. On the back side we're talking about probabilities. There's no difference. It's like talking about arc length and radians. There's no difference when we're in trig. So let's take a look at what this looks like in a diagram. Both of them are positive. Once again, think of this as a number line. I want to determine the area or the probability that the z is between these two values. Well, the probability that z is between those two values is the area between those two values. Probability is the same as area. So we're talking about this. We're looking at the z value, the area between 2.1 and 1.2. So I want to calculate this area right here. What our table gives us is the area from 0 to a z-score. What? Not in between two z-scores. So we're going to have to do a little bit of mathematical manipulation here. So let's first calculate or determine what's the area between 0 and 1.20. Let's look at our table. What's the area between 0 and 1.20? Molly, what do you come up with? 0.3849. The second one is 2.10. So what's the table say for 2.10? Allison?
42.
Now what that is this entire area. 0.4821. So my initial area is that. The 0.4821 is all that. What can I do with those two areas to give me just this area right here? Subtract them. So I have the 0.4821 minus the 0.3849. Once again, the hope is that you can see the visual with the diagram that you can, it will tell you what you have to do. So I can subtract those two off. What do we come down to? Come down.
0.0972.
0.0972, which is the probability. It's an area, it's also a probability. Questions you have? All right, you have the last 10 minutes here. You can start working on these. It's not difficult. It's just a matter of getting used to a procedure and a process to go through. Draw your bell-shaped curve every time. It helps you out immensely. Draw a picture, draw a picture, draw a picture. Okay, it eliminates little mistakes. And hopefully it will help you. What do I have to do? Add, subtract, add from 0.5, subtract from 0.5. I'm just looking at areas.